Alright everyone, so in this video I will be building this S550 Hexacopter frame. So if you're interested, watch along and I hope this video will be helpful to you. Now this frame is in the market for a lot of years. Now the original frame is from Holy Bro, and if you can read, we have some Chinese letterings over here. So I'm not sure if this is a clone or an original S550 frame. The S550 is a budget friendly frame which is made from good quality materials. So this is the stand for the drone. Then we have 6 arms. Now all of them are in the same color, which is black. Then we have some screws. Then here we have the battery holder along with an additional hardware which might be for the gimbal. And we have some adapters through which these pipes will be inserted. And we have some more screws, and these are the support for the landing gear and the frame. Then here's the bottom layer of the frame where the PCB is integrated. So we have the terminals, the positive and the negative, where we will connect the ESC and the power connector. And here's the top layer. It says S550 and we have the forward arrow. We don't have any instruction manual with this, and the electronics that I'm using are the same that I have on my S500 quadcopter. So I'm using the Ready to Sky 40 amp ESC, which is 4S capable, and I have the Ready to Sky DJI motors, and I'll be using some rubber dampeners to reduce the vibrations from the motor. So it's gonna be a hexacopter, so there are 3 clockwise and 3 anti-clockwise motors, so 6 in total, and 6 ESCs. And the receiver is a fly sky receiver, and as you might know that I've covered this in the previous video. So this is what will go on this frame. Alright, so let's begin with the assembly of the frame. Now firstly, since we have 3 packets of screws, let me just specify which pack will be used for what. So here the M2.5/6 will be used to assemble the frame and the arms together. Then these black screws will be used to assemble the landing gear and the legs together. And these screws, which are M3, will be used to mount the motors to the arms. So I'll keep the top frame aside for now. We'll work with the bottom frame first. So this is the top side of the bottom frame where we have the marking for the terminals, and this is the bottom end where there is no marking or anything, it's plain. So, and here's the leg, and this has a plastic part which is at an angle, so this leg or the post is site specific. So if I grab the bottom frame and invert it, also this is the stage where you'll have to decide if you want to orient the motors in the plus or the X configuration. Now because I've already set up my Pixhawk flight controller in the X orientation, the default direction or the frame layout is what is best. So since the arrow is pointing straight, we have an X configuration by default. However, if you want to use the plus configuration, you can use the frame like this and just ignore the arrow. I don't know if there is any difference in the flight dynamics, but I think the X configuration is better. So for the black screws, we have to use the 2.5mm hex wrench. So I'll grab a leg and place it here so that the 4 holes for the mounting bracket are aligned. Now, like I said, this is site specific. This is for the right side, because once the frame is flipped, this will go on the right side. You cannot mount this like that, because then the legs and the landing gear will point towards each other, so that's not what you want. And the screws will be installed through the holes from this side of the plate where we have the terminals. So here I'm assembling the left side of the leg. I'll insert the screws in the 4 holes and then screw them. Here I have to be a bit careful that I don't over tighten any single screw before all the screws are aligned. Otherwise there is a possibility that I can strip the threading. If you want, you can use some thread lock as well. Alright, so this leg is attached to the frame. Similarly, I'll attach the other one. So the legs are attached and here's how it looks. After this, we will now attach the landing gear. For this, we have to loosen the screw over here, again with the 2.5mm hex wrench. I will slide this on the leg. Now the third screw over here, I'll have to loosen that as well. So once that's in, I can tighten the screw slightly. Here I'll make sure to keep the landing gear aligned and I'll tighten the screw and then install the 2 screws on the side of the bracket, and also make sure to place in the nut if it falls off. So this is where the nut will go, in that bracket. So the left side of the landing gear is assembled. Now it's time for the right side. So I've placed it on the surface and made sure that the angle is correct for both the landing gear, and that way the drone is, or the frame is level. So now I'll tighten the screw once more. The landing gear assembly is finished. Now it's time to install the pipe and the adapters along with the battery holder. So here we have the ears or spacer, we can say, or whatever, through which the pipes will be installed, and we have some rubber grommets which have to be feed in like so. So now we will need the 2.5mm M2 screw. These adapters will be installed over here. So we have hole for the screw. So the first one will go here, second one here, third and fourth. And the screw will be installed from this upper side. We'll have to insert the screw through the hole and place the adapter from the bottom and secure the screw. Now to tighten the screw, we will have to use the 2mm hex wrench. I won't over tighten the screw yet because we have to slide in the pipe through the hole. So the ears or the adapter, whatever you want to call them, are installed, and now I can feed in the pipe through that. Now these are plastic pipes Nothing fancy about them. They're not carbon fiber or anything. So the trick here to install these pipes is you don't have to push them, rather you'll have to rotate it and then push. So that way it's easier to get the pipe through. So I'm pushing and rotating in the clockwise direction. If you want, you can use some oil to make this process a bit easier, and make sure you don't apply too much pressure because the frame could get damaged. So I've installed the pipe through the hole, equal amount of space on both the ends. So let me install the other pipe as well. We do have to apply a lot of pressure, but not too much of pressure. This is by far the most irritating or the tedious part about this entire frame, even with the S500. So the pipes have been installed. The bottom half of the assembly is more or less finished. Next we have this battery holder for the battery mount, and we do have additional plate. This one, I'm not sure what this is for, but this might be for the gimbal or an FPV camera. This plastic part will hold the battery mount plate, and these are Phillips head screw. So then this battery mount can be installed over here in the center, and if you want, you can adjust the position of the battery mount by sliding the mount itself. So then to install this plate, which I guess is for the FPV camera or any other hardware, we'll have to utilize these two ears as well. So they are not spare, we will have to use them and install on the pipe so that this plate can be installed. The groove on this hole is for the screw, so the screw can sit flushly. So the screws are now installed correctly. Alright, so now I'll be installing the motors on the arm, and I'll also connect the ESC, and then I'll screw in the arms to the bottom frame. And I'll be using these vibration dampeners for the motor so that I can eliminate some of the vibration that will travel from the frame towards the flight controller. So here I have the motors and the ESC that I'll be installing on the arms, and these are the screws that we have to use to mount the motors on the arms. These are provided with the S550 frame, and these are M3. So with the 2.5mm hex wrench, I'll be installing the motors. Alright, so I've installed one motor on the arm, and I've just used one vibration dampener because with the two together the thickness was a bit more, so the screw couldn't be installed. So here's how the motor assembly looks like. So ready to sky 2212 920 kV motor. This is counterclockwise. So similarly I'll attach all the motors. So this is the upper or the top part of the arm. So the motor will be installed over here. and I'm making sure that the screws don't touch the motor winding. So I'll set up all the motors off camera and I'll get back. So all the motors are attached to the arms. Now it's time to install the ESC. So like I said, I have this ready to sky 2 to 4S 40 amp ESC with me. Now if you want, you can remove the red wire from the connector, but I guess with the Pixhawk it's fine if you connect the red wires together because it has all the protection from the conflicting power inputs. Now we need to check if the clockwise and the anti-clockwise motors are spinning in the correct direction, and that's possible during the motor test. And if I have to reverse the motor direction, I can simply swap the outermost cables on the ESC. The center wire of the motor will always be installed on the center connector of the ESC. Now some might say that you can swap the middle and the outermost wire as well to reverse the motor direction, but I prefer swapping the outermost cables. I never mess around with the center wire if I have to reverse the direction, and I'll use a piece of foam tape to provide some cushioning for the ESC, and I'll use a zip tie to secure it. So similarly, I'll install the ESCs on all the arms, and then I'll attach the arm on the frame, and then we'll begin with the soldering process. Alright, so I've finished assembling the motors and the ESC on the arms. Now it's time to install the arms on the bottom frame. Now before I install the arms on the frame, I have to make sure that the clockwise and the counterclockwise motors are installed correctly. So here's the motor layout for a hexacopter for Pilot. So I'll have to follow this. So this is the forward direction of my frame, and the motors with the silver cap are counterclockwise and the black ones are clockwise. So first I'll install this counterclockwise motor, and I'll make sure that the wires are seated properly. And I'm going to secure the screw from the bottom, and I'll use the 2mm hex wrench. So the first arm has been attached to the bottom frame. We still have to secure the screws from the top frame. Now I'll install this arm, which has a clockwise motor, which will go over here on the right side. So the two arms have been attached so far. Now here I'll attach the motor number 3, which is a clockwise motor. Then I'll attach motor number 4, which is counterclockwise, and this will go here. Then here's the motor number 5, which is counterclockwise, and this will go over here. Alright, so now I'll begin with the soldering process for the ESC leads and the power module. So first I'll apply some flux on all the terminals. So I've applied solder on all the terminals of the frame. The power module leads will be connected over here. Alright, so the power cables for the ESC have been tinned. So now I can solder the wires to the terminals on the frame. Alright, so I've soldered all the power cables for the ESC onto the terminals of the frame. Now it's time to solder the power module to the frame. So on the power module, where we have the female lead for the XT60 connector, I'll have to remove this connector because on the male side is where the battery will be connected, and since on this S550 frame we don't have holes for the physical connector, I'll have to solder the wire directly on the frame. So I'm going to separate this female XT60 connector. So I've removed the heat shrink. Now with the soldering iron, I'll remove the wires from the connector. So the connector has been separated. I'll apply some flux on the cables and then tin the wires once more. Alright, so I've tinned the wires and now I'll solder the power module. So the power module has also been soldered to the frame. I did this off camera because I wanted to have a clear view while soldering, because I didn't want to burn anything or touch the soldering iron to anything accidentally. So the ESC cables have been soldered, the power module is ready. So now I can connect a battery and check if the ESC are working. But before I connect the battery, one very important step that I'm going to follow is, with the multimeter I'm going to check for any shorts or bridging between the positive and the negative. Put the multimeter in continuity mode and I'll check for any shorts or bridging between the positive and negative. So there is no beep, which means I can safely connect a battery. I'll plug in a 3S battery, and once I connect the battery I should be able to hear the ESC startup tone. I can feel all the motors beeping. So the soldering process is complete. Now it's time to install all the electronics and complete the assembly. To clean all the residue from the flux, I'll use some alcohol or sanitizer and I'll clean it so that it's neat and clean. Now it's time to install the Pixhawk flight controller onto the frame. Now I was thinking that I could mount this over here and then install the top plate like this, and as you can see that there is some space over here between the top plate and the flight controller, but here's the foam pad that I've got with the flight controller, and if I use this will sit somewhere over here and the gap would be very tight and all the vibration will eventually travel to the flight controller. So I'll connect the receiver somewhere here and I'll install the top plate. So then here's the FlySky receiver that I'm planning to use on this frame, but after a while I'll be using an Express LRS 2.4 GHz receiver. So then before I mount the receiver, I will make sure that the arrow on my Pixhawk is correctly aligned and where the receiver port is. So if this is how the flight controller is installed, then the receiver port is on this side, RC in, and the PPM out or the S bus port for my receiver is on this side. So I'll be mounting the receiver in this direction. I'll make sure that there is a 90-degree angle in between the antennas so that we have that Y formation at least. And I'll zip tie it to the arm. So I've applied a double-sided foam tape and place the receiver here. Then I'll connect the receiver cable, and since I'm using the S550 port, I'll plug it on the top side. And I've made sure that the connector is in the correct orientation. Now there's a lot of space around the receiver where I can install some other components as well, like a VTX or a FPV camera, but I'll be installing that later on. So I'll assemble the top frame. Now before I mount this plate to the arms, one important step is to mount this GPS holder or the bracket which will hold the GPS tube. Now since this will be installed on the top frame, the screw for this has to be installed from the underside of the top plate. So we have to install it at this stage. And to secure this GPS mounting bracket, I will use the vibration dampener which I've used for the motor, because that way we can eliminate some vibration traveling to the compass. So we have a long screw along with 3 grub screws that have to be used to secure the GPS mounting bracket, and I'll be using this rubber vibration dampener to soft mount the GPS holder. I'll be installing this holder on this side. So the screw can be installed on the smaller hole. We cannot install this holder where we have the wider holes. And I'll place this vibration dampener. And I'll make sure that the slot is facing straight so that we can fold the antenna base if we have to travel with the drone. Now apparently the screw that I've got with the GPS bracket is not the correct size. So I'm using the spare M3 screw that I got with the frame for the motors, and that's what I'll be using. So the GPS bracket has been installed. Then we have this part which has to be installed in the GPS holder, and we have to use the longer screw to secure it. Then here's the cap which will allow us to fix the GPS stick, and we do have a tiny hole here to secure this stick with the grub screw. After this I can install this cap and screw it in, which will allow us to orient the GPS in the correct direction. And when you're not using, you can rotate this cap and fold the GPS so that it's easier to carry. Alright, so now I'll install this top plate and secure the screws. So we have 3 screws for each arm, and that way the top plate will be secured and installed. So I've screwed in the top plate to the arms, and the assembly for the top frame is complete. Alright, so now I'll install the Pixhawk on the frame. So here's the forward arrow on the board, and on the drone also we have the forward arrow over here. So it's important to mount this in the correct orientation. And to secure the flight controller on the frame, I'm using a piece of double-sided tape. I'll be adding another layer so that any vibrations from the motor can be isolated or minimized. Before I actually stick this, the problem is the ESC wire for motor number 1 and 6 are a bit short because the pins for the ESC are on this side. So I have to mount this flight controller on the front side so that the wires can be plugged in. So that's the order of how the ESCs will be plugged in on this main output. And on the Pixhawk flight controller, bottom pin is the signal. In between we have the power line, and on the top we have the ground connection. The ESC wire has to be connected correctly. Alright, so the first ESC is connected. So because of all these wires, the Pixhawk has to be mounted a bit on the front end. Alright, so here's a close-up look of all the ESC connections on the Pixhawk. So the wires are now connected quite well, and it appears to be tidy as well. Now let's attach the power module. Now here's the next problem, because the power module cable is going to be a bit short. Yes, so I might have to push this slightly back, or the other thing is I could shorten the wire for this power module and then resolder them. So I've trimmed the wires for the power module so that the cable between the Pixhawk and the power module can be sufficient and there is no stress on the wire or the ports. First thing that I'm going to make sure is the power module cable is stress free. Alright, so now the power module cable is sufficient and it's plugged in quite well. So now I have to connect all the components. So here's the buzzer, which will go on the buzzer port. And I'll secure this somewhere here. The next is this safety switch. So I'll connect this to the switch port. And I'll secure this somewhere here. Later on I might route the wires from under the top frame so that we don't have this mess on top. Then I'm attaching the GPS module. So first the compass port on the I2C connector. And then this GPS connector on the GPS port. And I still have to attach this receiver cable. Now I should have attached this earlier, but I forgot. So let me install this. So the receiver cable, which will go on the RC in port. Actually I can bring this cable from the underside. So I've connected the receiver wire and I've routed it from the underside of the frame so that it's hidden. Actually this power module cable also I can get it from the underside of the frame, which might be a better idea. So let me try. So now I'll connect the GPS module to the GPS holder, and we have this metal part with the 3M tape. So I'll stick the foam tape, and the quality of this 3M tape is quite good. If you want to remove this, you'll have to apply a lot of pressure. And to secure this to the antenna stick, we will have to use this tiny grub screw and then mount it like this. The only crucial step here is to maintain the arrow direction so that it's parallel to the flight controller. So I'll mount this first. So once this is installed, now in Mission Planner I'll make sure that the compass of this external GPS module and the compass in the Pixhawk are as close to each other, and only then I'll stick this on this circular base, so that way the heading of my drone is accurate. So I hope everything powers up and I don't see any smoke. Alright. So I've pressed the safety switch. So now the drone can be armed. And I've given the arm command, but there is some error, which is why the buzzer had some sound. So I'll have to check in Mission Planner. Now, because I'm indoors, I don't have any GPS connection. So that could be the reason. So before I mount this GPS on the stand, I want to make sure that the compass for this module is parallel to the compass of the Pixhawk so that the heading can be accurate. So I have to connect the Pixhawk to Mission Planner, and since I have this telemetry kit with me, I'll connect this and make all the changes from the computer. So here's the telemetry cable for the transmitting module, and here's the 6-pin connector that will go on the telemetry port. So we can connect this on either telemetry 1 or 2. We have 2 telemetry ports on the Pixhawk, so I'll connect this on telemetry 2. And I'll place this module somewhere here for the time being. And then here's the receiving telemetry module, which I'll connect to the computer. We can also connect this to a mobile device with this OTG cable. So I've connected this telemetry to the computer. I'll have to connect the battery. First, I'll also turn on my transmitter, then plug in the battery to the power module. And the LED on the telemetry module is solid green on the transmitting and the receiving module as well. So the link is established. I'll press the safety switch. So I'll launch Mission Planner, and from Device Manager I'll also check on which COM port the telemetry module is connected. So it's on COM 17. So in Mission Planner I'll select COM 17 and baud rate to 57,600 and click on connect. And it's loading all the parameters. Alright, so I'm just going to connect this GPS module on the antenna base, and if I need to recalibrate the compass, then I'll do that. Now, very important to make sure that the arrow is facing in the forward direction. So it's pretty much aligned. I'll press to secure it. And now I'll restart the Pixhawk flight controller. So I'll disconnect the battery. And connect in Mission Planner. So I guess I can arm the quad. So I'll hold the left stick. And the motors are spinning. Alright, so I'm able to arm the quad and the motors are all spinning, so they're working well. I just have to make sure that the motors are spinning in the correct direction, because if they're not, I might have to switch the outer two wires for the motor on the ESC. And I also have to perform the motor test in Mission Planner. If we run all the motors in sequence, like motor A, like test motor A, B and C, D, E, F, and if I click on test motor A, this motor will spin. Then we have B, C, and so on. So the lettering is in order, so we have A, B, C, D, E and F. However, the numbers are not in the order. Here's the correct numbering for the motors. So 1, 2, 3, 4, 5 and 6. And this is a bit confusing because if you make any mistake over here and you try to fly the drone, it's not going to fly. It will crash or fly somewhere else. So we have to be sure of this lettering and the numbering. So the counterclockwise motors are spinning in the correct direction. I have to reverse the clockwise motors. So this, and this. The one with the black cap are clockwise. So I'll have to reverse them. So I'll have to disconnect the battery. And I'll switch the outer two cables that are connected to the ESC and motor. So I'll swap these two wires. So the wires have been swapped. So I'll do this for all the clockwise motors. Alright, so now I'll be calibrating the ESCs on the hexacopter. So to calibrate the ESC, first you have to make sure that the radio transmitter is bound to the receiver, and we have to calibrate the radio transmitter first, because with the Pixhawk we have the option to calibrate the ESC directly from Mission Planner, and for that you have to have the throttle channel calibrated in the radio calibration setup. So here in the radio calibration screen, I'll click on calibrate radio and click on OK. And now we basically have to move the sticks to their endpoints so that the channels are correctly mapped. So basically I'll just move all the channels. And once that's done, just click here where it says click when done. The radio has been calibrated. So once the radio calibration is successful, we can see the minimum and maximum channel values which are calibrated in the flight controller. So click OK to proceed further. So after this, we can calibrate the ESC. So then in the ESC calibration menu, here we have some options. So firstly, we have the ESC type. Now if you're using any other ESC like the BL S or just the BL series, you can select the appropriate ESC protocol like the D-Shot 600 or one shot. Since I'm using the ready to sky 40 amp ESC and they don't have any specific protocol as such, I'm just going to select normal and rest will be default. All you have to do is just follow the basic instructions which are mentioned over here. So once we click on calibrate ESC, make sure that you don't have any propellers on the motors, and after pushing this button we will disconnect the battery and then plug in the battery again, and the LEDs on the Pixhawk will flash and we have to press the safety switch and all the ESCs will be calibrated automatically. We don't have to mess around with the throttle channel, unlike how we have to do on the APM flight controller by using the channel 3 or the throttle channel. So I'll click on calibrate ESC and disconnect the battery from the drone and plug in the battery again. At this stage, like I said, I have the throttle all the way down. I'm going to press the safety switch and we should hear the motors beep, which will indicate that the ESC has been calibrated. So we could hear the ESC beep and followed by the regular startup tone from the buzzer. So last step in the ESC calibration is to restart the flight controller. So I'll reconnect the battery once more. Alright, so then the ESC calibration process is complete and we could arm the quad and check. After this, we could move on to the flight modes. Now from the mixer page of the radio transmitter, channel 5, which I've set to SC, which is switch C, and it's a 3-position switch. Here in Mission Planner we can see that the first flight mode I've assigned to stabilize mode. The middle position is set to altitude hold, which is flight mode 4, and the very bottom position of switch C is set to loiter. If you want, you can choose any other flight mode that you'd like. Just keep in mind that you will require GPS connection to fly the drone in certain flight modes such as altitude hold and loiter, and various modes where the drone needs GPS coordinates. Now one more step that I'd like to mention at this stage is you might have to reverse the pitch on your radio transmitter, or at least in the Mission Planner software, because just like the APM 2.8, I've read and I've also observed that with the Pixhawk, especially with the FlySky radio transmitter, the pitch axis is reversed when you're flying the drone, and you can correct that with 2 methods. And to check physically if the pitch is reversed, what you can do is you can install the propellers on the motors and give a tiny amount of throttle and then push the pitch in both the direction, and you will observe that the drone will either lift forward or push back, and then you can decide if you have to reverse the pitch or not. 99% of the time you will have to reverse the pitch on your radio transmitter, or at least in mission planner. So to reverse in the radio transmitter, go to your model setup, and in the output page select channel 2, which is the pitch axis. Click on edit, and you can invert the direction and save it, or the other option is go to the config tab and select advanced parameters. If you don't see the option of advanced parameters, click on planner and make sure that your layout is set to advanced and reboot mission planner. After that, you will see some additional options such as the advanced parameter option. So go to advanced parameters and click on find and type in RC2 and click OK. And here, if we scroll down, you can see that RC2 reversed, it's set to normal. So if you want to reverse channel 2, which is for pitch, through mission planner, select reversed over here and click on write parameters. So now the pitch axis will be reversed within the Pixhawk flight controller itself. So I thought I'd mention that in this video itself. Next, I'd like to show you guys how to set up the arm and disarm switch for the Pixhawk. So firstly, make sure that you have an auxiliary channel set up for a two-way switch or a two-position switch like the switch A on this radio transmitter. And then in mission planner, click on config and click on extended tuning, and here we can see that we have some options for RC6, RC7, 8, 9 and 10. So here we can select what function we want for the aux channel. So for example, I've set RC6 to arm and disarm, and this feature is available from Hexacopter firmware version 4.2 onwards. So here I've selected arm and disarm. If you want, you can also select arm and emergency mode to stop. The difference between this and arm and disarm is that, so for example, I've selected arm and emergency mode to stop for switch A. So if I arm the drone and raise the throttle, I can disarm mid-flight and arm again. So this is with the arm and emergency mode to stop function on switch A. Whereas if I select just arm and disarm and click on write parameters, you can see the difference. So this is with the arm and disarm feature on switch A. So if I arm and now if I disarm, I won't be able to arm back again mid-flight, because now the throttle is beyond the arming range. So that's the difference between the arm disarm and the arm and emergency mode to stop option. So depending on which option you find better, you can select that. And again, this feature is exclusive to the Pixhawk flight controller. We don't have this option with the APM 2.8 flight controller. And here in the initial tune parameter option, once we have completed calibrating the accelerometer, the compass, the radio calibration and ESC calibration, along with the 3DR power module for the voltage and current readings, we can initialize the tune parameters. So where it says air size in inches, just type in the size of the propeller that you'll be using. So I'll be using 10-inch propellers for these motors. So here I'll type 10 and battery cell count. So the LiPo battery that you'll be using to fly the drone. I'll be using this 4S LiPo battery from GNB. So here I'll type in 4. If you plan to use a 3S battery, make sure to type 3. So then the battery cell voltage when it's charged all the way. So the cell voltage of a fully charged LiPo is 4.20 volt. So 4.2 is selected over here. And battery cell when it's fully discharged. So I've set this to 3.3 volts. And the battery chemistry is set to LiPo. So make sure to set the right settings according to the battery that you're using. So, and then click on calculate initial parameters. And here Mission Planner will display a few values which will be calculated based on the numbers that we just typed in. And make sure to click on Write to Flight Controller. And the parameters will be successfully uploaded to the Pixhawk. So some of the topics that I have to cover are the failsafe settings for the Pixhawk, then how to set up the RSSI for the telemetry, and how to set up the telemetry module itself. So these are the topics that I'll cover specifically in different videos. Apart from this, most of the settings I've covered in the previous videos where I've set up the Pixhawk flight controller, and you could check those videos if you want some help or guidance. So I've completed all the settings. Now all that's left is to test the drone and fly it. So make sure to subscribe and stay tuned for those videos. So that's all I had to share in this series of how to assemble the S550 frame and set up a Pixhawk flight controller. So I hope you found this series helpful and informative. That's all for now. I'll see you guys in the next one.